Today, let us see final control elements that we'll see today. Final control elements. What is the drawback with valve? What are the drawbacks with valve? Whatever may be the design, even if you design very theoretically linear, it won't function as linear in the practice. That's why non-linearity in the valve is the drawback. Second one is cavitation and flashing problem. Cavitation and flashing. Cavitation and flashing problem will be there. Third one is cavitation and flashing problem will be there. Third problem is the major problem. Power drop in the valve. What is power drop in the valve? The valve always should open for 50%. Why? Why valve has to open always 50%? Why don't you 100%? Let us assume that the tank has to be filled for 5 feet. If you design a valve, if you open 100%, it fills for 5 feet means you can open always valve 100%. Why always we are opening 50%? Why? Because to maintain constant flow. Why 50%? Because if you open more flow rate, you can design smaller valve and keep 100% open, you know. Why 50%? Flow rate is function of upstream pressure. Flow rate is function of upstream pressure as well as density. If upstream pressure changes, flow rate may change. Suppose upstream pressure decreases. You opened 100% for 5 feet. Upstream pressure decreases. Flow rate will decrease. But valve opening how much? 100%. You can't open beyond 100%. You cannot adjust. You cannot control. That's why the nominal value must be 50%. If you want to open more, there must be a provision to open further. That's why the valve capacity is 10 LPH means we'll use only 5 LPH one. Because our requirement is only 5 liters per hour for the given upstream pressure. For given upstream pressure, it can give up to 10 LPH, but our requirement is only 5 LPH. Why you are putting higher capacity? Because if any change in upstream pressure, the flow rate will decrease. For that, we have to open the valve more. By that way, only we can increase the flow rate. That's why always valve will be opened for 50%. I am telling in the other way. Always valve is closed for 50%. It means you are dropping the pressure across the valve. There is a pump that pumps the liquid for 100% flow rate. 50% is dropped in the valve. So power is dropped. Electrical power is wasted by closing the valve 50%. Am I correct or not? So valve is closed always 50% means deliberately you are wasting the power across the valve. 50% of the power is wasted. Suppose you are pumping 1000 liters per hour. 1000, not 10 liters. In the lab, we are having some 10 liters per hour. 5 liters per hour or 10 liters per hour. 10 LPH. In industry, you have to pump a 400 megawatts power station is there. How much liquid is required? So you are pumping 100 LPH, 1000 LPH you are. So what is the power, electrical power you are spending? You think about it. But 50% of the power is wasted. Let us assume that you are using 100 HP motor. But it can pump 100 liters per hour. 100 HP, let us assume. It can pump at 100 liters per hour. But your requirement is 50 liters per hour. That's why you close the valve 50%. It pumps 50 liters per hour. But how much power it is spending? For 100 liters. Then only there will be a flow rate of 50 liters. 50 liters of power is wasted just by dropping the pressure across the valve. So valve absorbs power. There is a power drop in the valve. Then only we can operate. That's why we are allowing to drop across the valve. Have you understand that these are the drawbacks of the valve? Power is spent on the valve. I can tell this way. We are spending power on the valve. We are spending electrical power on the valve, or we are wasting power across the valve. I can say that way also. We are wasting the power across the valve. So that can be solved by using VFD, variable frequency drive. That is another final control element. Still, in many industries, they are using valve. But if you replace by valve, suppose their electrical bill is for 2 lakhs per month, means if you replace valve by VFD, you can reduce 50%. Because 50% power is saved, 50% power is wasted across valve because valve is closing always 50%. So if you replace by VFD, variable frequency drive, you can save power. How? That we will see now. Suppose you are having a pump. This is the pump. This is the pump coupled with this is the pump coupled with three-phase induction motor. Three-phase induction motor. How we can vary the flow rate of the pump? By varying the speed of this motor, or you can put suppose this three-phase induction motor is rotating at constant speed, means you can put a valve here, you can put a valve here, and you can adjust the flow rate. It means what? You are deliberately wasting the power of this motor by blocking the line. Instead, what we can do is, I am having a pump that is coupled with the three-phase induction motor. Three-phase induction motor. Three-phase power supply is given. Here, if I vary the speed of this induction motor, I can vary the flow rate. Why I have to go for valve? No need to go for valve. Vary the speed. If you vary the speed of this induction motor, no need to have valve. How the speed can be varied? N is proportional to 120 F by P. P is number of poles, that is constant. 120 is constant. Therefore, N is the speed of the induction motor is proportional to F. So if you vary the frequency of power supply, you can vary the speed from 0 to maximum. Suppose this induction motor is rated speed of 3000 RPM. 3000 RPM. Rated speed is, synchronous speed is 3000 RPM. Its rated speed will be 2800 like that. Synchronous speed is about 3000, means its speed will be, rated speed will be 2800 like that. So if you vary the frequency F to this, we can vary the speed from 0 to 2800. That is very much possible. For that, you can use variable frequency drive. Variable frequency drive is a power electronic device. Power electronic. What is the difference between electronic and the power electronics? Electronics means low voltage, low current. Power electronics means high voltage, high current. If electronics handles high voltage, high current, then it is called the power electronics because it handles 440 volt. That's why it is power electronic device. For that, we are giving either 3-phase power supply, 440 volt, 3-phase 50 hertz power supply is given, or 220 volt single phase power supply. In our lab, we have 220 volt single phase power supply VFD. And if we give 4 to 20 milliamp signal, 4 to 20 milliamp signal, the frequency here, the voltage is 440. Output of this VFD is 440 volt. But the frequency varies from 0 to 60 hertz. The frequency, you are giving constant frequency input power. The output power is constant voltage but variable frequency. Because N is proportional to F, you can vary from 0 to maximum speed. There is no need of a valve. That's why power is saved. Power is saved. If you use VFD, variable frequency drive, power is saved. VFD, variable frequency drive. So what is VFD? VFD will take constant frequency power, either 220 volt single phase or 440 volt 3-phase power supply. It will take and give 440 volt 3-phase variable frequency from 0 to 60 hertz. 60 hertz depends upon the input signal, that is 4 to 20 milliamps. 4 to 20 milliamps. For 4 milliamps, frequency is 0. For 20 milliamps, frequency is 60 hertz. That's why we can adjust the induction motor speed just by varying the signal 4 to 20 milliamps. That is happening in the flow process. Both cases we are using in the lab. In the level process, you are having a valve. You are giving 4 to 20 milliamps to the I to P. The I to P convert the signal of 4 to 20 milliamps into 3 to 15 psi. That 3 to 15 psi operate the valve. That's why flow rate is varied from 0 to 100 LPM. Sorry, 10 LPM. 0 to 10 LPM. By opening the valve, we are adjusting the level process. In the lab, we are having flow process also. In the flow process, we are not having any valve. Instead, we are having a VFD. The input power to the VFD in the lab is 220 volt single phase 50 hertz. The output is 440 volt 3-phase 440 volt 3-phase variable frequency. The frequency varied from 0 to 60 hertz depends upon the signal 4 to 20 milliamps. Depends upon the signal 4 to 20 milliamps. That's why we are varying the flow rate just by varying 4 to 20 milliamps. That is about VFD. Thyristor, power controller. Suppose you are giving power directly to the process. For example, we are having a thermal process in our lab. The thermal process, to heat the process, heater will be there. Heater will be there. We are giving 220 volt 50 hertz power supply. How to vary this amount of heat supply to this furnace? We have to vary the power given to this. To vary that power, there is a power electronic device called TPC, Thyristor power controller. You have to give 220 volt 50 hertz power, constant power to this. Here, it will vary the voltage 0 to 220 volt. The TPC will vary the voltage from 0 to 220 volt, so that power 220 volt, 0 to 220 volt. TPC will vary the output voltage. TPC will vary the output voltage. That is also another power electronic device.